of functions. That's section 3.4. So from functions, we can create new functions. So given f of x and g of x, we can create the sum, the difference, the product, and the ratio. Quiet, please. So sum, difference, product, and quotient of these functions to create new functions. And we have special names that are very self-explanatory. I know you've seen this before, many times before. Okay, so this is called f plus g of x. What do you think it would equal to? Common sense. Good. What about the other one? The next one? That's it. What about the next one? Awesome. What about the last one? Awesome. However, this one comes with an if. Great job. Of course, if g of x does not equal 0. There is another possibility. And the other possibility of creating new function is called function composition. I want to practice with the problem, all these, and then we look at function composition. So on page 218 from your book, let's select two functions or any problem from here. It says 1 through 15, odd, whatever you want to choose. So let's pick a problem in which we are given two functions and we are asked to find the sum, difference, product, etc., etc. And then we're going to look at the fifth possibility. Also, I want to caution you on something very important before you select. If you selected, that's fine. Please let me know. Here's a situation with two functions, and I'm going to graph them. Here's one function, function f of x. And here's function g of x. I'm going to put some numbers here. Let's say 4. Let's say 15. Let's say -2. And I'm going to ask you to find f plus g at 10. You will say that's a piece of cake, right? It's f of 10 plus g of 10. We know that. However, there is a problem. Yes, please, Mike.
Wouldn't it just be undefined?
Correct. So f of 10 exists. G of 10, this is g of x. G of x exists. G of 10 exists, but f of 10 does not. So this does not exist. And something plus undefined is still undefined. So looking at this graph, can you please tell me what values of x I can ask you to evaluate the sum or the difference or the product or the ratio for? Yes, Mike?
Bracket 0 to 4.
Of course. Exactly. So my caution to you is common what? Common? That's a good one. No, but common domain. Awesome. Thank you, Mike. This is indeed the common domain. So if these two functions did not have a common domain, nobody would care about this. Nobody can create it because it doesn't exist for any x value. That's exactly what happens. So if the two functions do not have a common domain, the sum, difference, product, and ratio have no meaning. They don't exist. They cannot be created. So the common domain is crucial when we add, subtract, multiply, divide functions. Okay, since you haven't chosen, I will. Let's say number 8 on page 218. So we have f of x, 1 over x minus 4, and we have g of x, which is 1 over 6 minus x, and they're asking us to find the whole bunch. The sum, the difference, the product, and the ratio. Ready? Where is our starting point?
State restrictions.
Awesome. Finding the domain of each. Great job. Why? Because rational functions, I like to call them not friendly. They're not defined everywhere like polynomial functions, like exponential functions. They're not friendly. So what will you say x cannot be? Awesome. And x cannot be? So now please give me the domain of f, and please give me the domain of g. The domain of f is? Perfect. Great job. And the domain of g? Very good. What do you think I'm going to ask next? Exactly. Because the common domain will always be the domain of the sum, the domain of the difference, and the domain of the product. It may or may not be the domain of the ratio. I cannot list it. It could be, but I cannot list it for sure and forever. So the problem is also asking us to find the domain of each function, the sum, difference, and product. Once I have established the common domain, it's the same. I don't have to write it again for the sum, product, and difference. So can anyone give us the common domain? Very good. Very good. Very good. So the common domain must exclude both values because one or the other is not defined. Excellent. We don't have to write this again. This is the domain of these three functions, always and forever. Okay, so now let's create them. So f plus g of x equals f of x minus plus g of x. I copy them, so please write the definition first. And I copy them 1 over x minus 4 plus 1 over 6 minus x. Now, I don't know if they want the answer fully simplified. Let me see. I would have, so for each, determine the domain for each function in interval notation. And find these. So domain, and so what I would do, I would definitely arrange this in descending order and factor out -1. Change it into 1 over x minus 4 minus 1 over mx minus 6, and find the least common denominator. Not just leave it as is, as a sum of two rational expressions. So the least common denominator is, we've done this before. Yes, the product, very good. So then what are the adjustments? And x minus 4. And be careful now with the minus in front. So we have x minus 6 minus x plus 4. And the numerator becomes -2. I don't know exactly what they want, but this is the fully simplified expression. In the same way, I would like you to do the difference. So we can look at the product. Same. It's going to be plus here, right? So it's going to be a difference here. Instead of a difference, it's going to be a plus. So please perform that. So we can look at the product. Please write the definition as f of x times g of x, always before you start replacing them. And then we have 1 over x minus 4 times 1 over 6 minus x. The only thing I would do here is pull out the negative and just write them side by side. We do not multiply the factors in the denominator. We work very hard to factor the denominator. So please do not ever waste your time on foiling that. Always keep the factors as they are in the denominator. I would like to look at the ratio, however. Please stop if you have questions. So we have f of x divided by g of x. We have to write the definition first. 1 over x minus 4 divided by 1 over 6 minus x. I know how to divide two fractions. I would keep the top and flip the bottom. However, at this point, I have to state a restriction, if needed. I have to write that g of x is never 0. This is extremely important. But is g of x ever 0? When is a fraction 0? Only when the... no, that's undefined. Only when the numerator is 0. But can 1 be 0? No. Since this is not possible, I can go ahead and flip. So I have 1 over x minus 4 times 6 minus x over 1. There is no extra restriction that I have to state. So all I will do is this. Pull out a negative and write x minus 6 over x minus 4. And that would be it.
Could you do an example where that doesn't work?
Where we have to add additional restrictions? Yes, I will. Yes, please. I pull out because it's 6 minus x. So 6 minus x is negative x minus 6. Yeah, because we like to keep everything in descending order and no negative leading coefficients. So here's an example. Let's say f of x equals x squared. And let's say g of x equals x minus 6. So when we want to determine f over g, so both the domain of these two functions is what? And the common domain is what? They're polynomial functions. X squared and x minus 6 have no restrictions whatsoever, right? They're polynomial functions. So the common domain is everything. But when I determine the domain of the ratio, so that this is going to be the domain of 3 more functions, the sum, the difference, and the product, always. But the question is, what would happen with the ratio? Please write f of x over g of x first, and then write x squared over x minus 6. And now you have to say, oops, now there is a problem. I never had any problem with the sum, difference, product, but I have a problem with the ratio. What is the problem with the ratio? X cannot be? Indeed. So the domain only of the ratio, can anyone give it to us? Awesome. Great job. That's it. So although initially both functions had the domain all real numbers and the common domain was all real numbers and everything worked for the sum, difference, and product, it doesn't for the ratio. Is that clear? Perfect. Okay, last method of finding new functions or creating new functions is function composition. Function composition. This is a totally new way, totally different. It's not the sum, it's not the product, it's not the difference, it's not the ratio. So the notation is, I'm sure we've seen this. So this is read F comp G. Extremely important for calculus. Of course, I can create G comp F. I can create F comp F. I can create G comp G. I can create G comp F comp G. And you can go on forever. So, what is it? Yes, please. Great job. So, let's take a look at this time at 3 bubbles. And we want to define f comp g. By definition, this is f of g of x. F of g of x. So from the very beginning, I would like to establish what is this function called and what is this function called. G is the inner function, which means it's applied to x first. What do you think f is called? The outer function. And it's applied to the result of g. It's not applied directly to x. So since g is applied to x first, here's x. We apply function g. What do I get? Awesome. To this number, we apply function f, and we get f of g of x. This is the domain of f comma g. I need to caution you, there is no requirement of common domain. When we create a function composition, we do not care whether they have a common domain or not. But we do care about something else, more complicated. So when we determine function composition, the requirement is not the same. We don't care whether they have a common domain. They may, fine. They don't, fine too. However, here's the problem, right here in the middle. What is the problem? So this is what's set for G. What set is this for G? What do we do it? How do we call it? We determine it all the time today. What do we call this set for function G?
So that's a different domain.
Domain for G. What is this set? I'm going to write it. What is this set for G? If this is its domain, what could this be for G?
Domain of g of x.
The range, right? Right. So this is a domain where x values come from, and this is where the function of y values come from, right? So this is G of x, right? These are the range values. Good. So this is domain for G, and this is range for G. But also, this set is what for f? Right, that's the problem. So if I bring here, let's say 5, but f is not defined at 5, I'll never get there. So the problem here is more sophisticated. It's based on the fact that the domain of f and the range of g have to work well together. If they don't, we cannot create a function composition. You see, it's a different level of requirement. Okay, so let's look at an example with function composition. Different story, way more sophisticated. So maybe I should write this here, okay? So this is also domain of G. This is also range of G. But at the same time, this is what? Exactly. Yeah. So the problem is we don't care whether they have common domain or not. But the problem is that if this does not work well, then the function doesn't exist. And yes, we will have some conditions to state on that in a minute. Okay, so we have several problems to select from. We have the following exercises. Use each pair of functions to find f of g of x and g of f of x. Simplify your answers. If my colleagues did not select any of the problems, this is not a simple situation to find the domain of function composition. If they did not select the domain here, I will not bother you with it. It's not an easy situation. But if they do, I'll have to show you at least the problem. So for now, let's just look at, so let's start with problem 13. page 218, and we have f of x equals the square root of x plus 2, and g of x equals x squared plus 3. The problem is asking us to find f comp g and g comp f. They're not asking us to find the domain. So use the set of functions to find f comp g and simplify your answers. It doesn't say anything about domain. Okay. So please write the definition first. F comp g of x is f of g of x. Then please write inside f, replace g of x by x squared plus 3. And only now look at f. F says to us f of blah equals the square root of blah plus 2. Now, in this case, blah is
X squared plus 3.
awesome. So please tell me what to write. And outside plus 2. Great job. Thank you. Now, the other one, g comp f, please write the definition. I didn't mean that, sorry. I meant to write g. I'm going to fabricate a g from this. G of f of x, which is g of the square root of x plus 2. And now carefully we look at g. G says g of blah equals blah squared plus 3. But what is blah now? Very good. And then plus 3. We have an agreement from day one on binomials. Although you can say, but this is not a binomial, I will have to say, not really, it's not a polynomial, it has a square root, but the procedure is the same. So we need to simplify this. First term squared plus 2 times 2 times the square root of x. 4 the square root of x plus 4 plus 3. So this is x plus 4 the square root of x and plus 7. Before we look at, there is an example with the domain of function composition, so we'll look at it in a minute. I want to look at function decomposition. Why is this needed? For the next class. Okay, so I want to caution you there is more than one correct answer here. So let's say I have a function that is 1 divided by the square root of x plus 3. And I would like you to decompose this function into an inner, let's call it g of x, and an outer, let's call it h of x. So when I say inner, when I ask you for finding an inner function, you will look at this expression, you will say, if I'm asked to evaluate this function for 5, which quantity, which function, if you want, I will have to evaluate first. And that will be your inner function. If I want to evaluate for 5, what piece of all this will I evaluate first? I can't get to the square root just yet. What is the first step? Not the square root is the first step, but the first step is? Say it again.
Fraction then.
No.
Okay.
So when I evaluate for 5, do I do the ratio first? Do I do the square root first? Or I do the... Exactly, the sum first, right? Don't I have to add first before I get to the square root? Don't I have to write 5 plus 3 first? before I apply the square root to it? Correct?
Yes.
Good. So now give me another function that you will apply to a number. Since we only want two functions now, what function will you apply to this number? Exactly. H of x is 1 over the square root of x, indeed. So that's what we call function decomposition. Is there a more than one correct answer? Yes. Okay, let's look at another. Let's say g of x this time is the absolute value of x squared plus 1. I would like you to give me an inner and an outer. Let's call it g. I'm sorry, I used f. I have to use f now. It doesn't matter, and h of x. So how do we decompose this?
So with an inner function of that.
So the inner function would be
Like,
good, and now I get a number here.
absolute value max.
That's it. So there are many examples that my colleagues suggested here, but I think we needed something simpler than that first. So now we can choose 33 if you'd like on page 219. And this is h of x, which is the fourth root of 3x minus 2 over x plus 5. So we want an inner. Let's call it g of x, and an outer. I didn't say it, but I'm sure it's clear to you, but let me write it one more time. So this is f of x, which will be h of g of x. Inner, outer, correct? The same thing here. Okay. So we want an inner and we want an outer. Just two functions. What would be the inner? Excellent. And we're done. We just get one number here. Which function we apply to this number? Very good. The fourth root of x. Great job. Any questions? I would like to, so this is the only problem that my colleagues selected, which is, it says, for this function, f of x and g of x, write the domain of f comma g in interval notation. That's the only one. So we selected from here. I know I have only, 8 minutes left? No, 9 minutes left. So I would like you to choose. This is one option. Or we look at reading from these graphs, which is very important. Quiet, please, please, please. And reading from this graph or a table. And that will be the end of this section. So let's read quickly from these graphs and see what happens. So, for example, let's look at 51. It says g of f of 2. So it says, shown in figure 6, f is here, g is here, h is here. So they want us to find g of f of 2. Where is the starting point? What do I have to determine first? Very good. So I go to this graph, and let's identify f of 2 here. F of 2 is 4. So now I have to determine g of, very good, I go to g, and here is g of 4. 2. Is that clear?
Yes.
Okay. Let's look at the table now. So let's say f of g of 5. What do I have to determine first? G of 5. So I go to 5, and g of 5 says 8. And now I have to determine f of, okay, I go to 8, and for f of x, and I get 9. Perfect. So I think we have no difficulties for this. And we have no difficulties for this, I'm sure. So let's work on that problem. Ready? Oh, I'm sorry. Sorry. Okay, so problem 25 on page 219. which means that we have not accomplished the last two sections of this chapter. So the last two sections of this chapter will be moved to the next test. And they are 3.5 transformations, 3.6, actually 3, absolute value functions, and 3.7 inverse functions. So 3 sections will be moved to the next test.
So all of 3.3 and 3.4 will be on this.
Yes, yes. Everything we studied till including today. So f of x is 1 over x, and g of x is the square root of x minus 1. Write the domain of f cum g. F cum g. In order to find the domain of f cum g, we will not determine f cum g. Determining f cum g will not lead us to the domain. Do not find f cum g. Okay? There is a different procedure for finding the domain of the function composition. So I know that this is f of g of x, and I know that the sequence will be to x, which function do I have to apply? Very good, g first. I get g of x, and then to this number I apply f to get f of g of x. Great job. Okay, so then I need to establish the domain of g. I look at this function, and I know, please say what I need to write for this function. Awesome, thank you. So this domain is definitely 1 to infinity. Do you agree? We know how to graph this function. Imagine how to graph this function and give me the range. So this is domain of g, and now I want the range of g. Excellent. Do we know that, right? So this is the square root of x, and this is the square root of x minus 1. Of course, the range is still all your 0 to infinity. Perfect. Now let's look at f. I only care for the domain of f. Can anyone give us the domain of f?
Negative infinity to 0.
Very good. Negative into 0 union 0 to infinity. Okay, perfect. So what could be the problem? What could be the problem here? That g is applied to a number that brings what here that I cannot apply f to? 0, right? So if g is applied, let's say to 15, I'm making up a number. If g is applied to 15 and I get g of 15 to be 0, then the chain is broken because I cannot apply f to 0, correct? So I have to make sure that g of x is never what? Correct. Very good. Awesome. So make sure that g of x is never 0. Why never 0? Because I cannot apply f to 0. Good. What is g of x? Can anyone dictate g of x? Can anyone dictate g of x? I'm talking about g of x. Careful. I'm only talking about g of x. Very good. So the square root of x minus 1 cannot be 0. Which number will make this 0? So x cannot be 1. So I go back. I remove it from the domain. Is 1 in there? Good. So I'll say not x equals 1. And that becomes the domain of the function composition. So f cum g, the domain of this function, is 1 to infinity. As you see, it's a